did we get to know what plate tectonics even were? The first people who came up with theories were map makers. When they made the maps, they realized that the continents fit together kind of like these puzzle pieces. Next was a scientist, Edward Seuss, to first put this theory into the science world. He came up with the Gondwanaland, a one large landmass. Next, Alfred Wegener came along. He came up with Pangea, and he actually had some information to back up his ideas. Wegener's hypothesis. His hypothesis was called continental drift. Continental drift is when the continents used to be as one large landmass called Pangea, but over a very long period of time, they moved. What was his evidence of this could happen? First, the fact that on each continent there were matching animal fossils in the same type of rock. How could animals adapt to the same climates and areas if they weren't in the same place? And somebody might say they switched continents, but most of these animals in the fossils could not swim. There was no way they could have crossed the ocean. Yet, they were still identical on either continent. His next set of evidence was that there were similar rock layers on either continent. How could the rocks form in the same way in the same time period if they weren't together? And third, like the mapmaker said, they fit together like puzzle pieces, like they had once been together. The one problem was, how could these land masses move? They were so huge. This is why people did not believe him, and it took a very long time for this theory to become accepted by the mass majority. But now we have the answer. Convection. Convection, in this case, is when the molten magma under the Earth creates different currents, which moves all of the crust and the tectonic plates. This creates the continental drift and moves all of the continents to where they are today. As you can see in the diagram, the two masses are pulled apart by the current underneath the grip. There are several types of plate tectonic boundaries. The convergent boundaries are continental, continental. Another is oceanic continental. And finally, oceanic oceanic. There's also a divergent boundary. This is caused by ridge push slab pull. And finally, the transform boundary. strike, slip. In a continental-continental boundary, two continental plates are forced together. They then create a folded mountain as they push together. In oceanic-continental, the oceanic crust subducts underneath the continental crust. It then melts and forces the magma upward to cause volcanoes in a volcanic arc. In oceanic-oceanic, two oceanic plates converge. One subducts underneath the other, forces magma upwards, creating islands in an island arc. There may also be some volcanoes. This divergent boundary, magma is forced up, hardens into rock, and comes out the crust. It then moves along the surface and subducts again into another area, causing a trench. And finally, the transform boundary, in which two plates slide next to each other. They do not create a mountain, but they pass by each other that may cause earthquakes. Now on to mountains. Mountains are formed from the converging or coming together of tectonic plates. They are also formed from the diverging or separating of tectonic plates. There are several types. A folded mountain is caused by the converging of tectonic plates. As they converge, they force the crust in between the movement to be wrinkled up into a folded mountain. Ridges are also created. These tend to be an oceanic crust under the ocean. This is when the tectonic plates separate and magma moves up to fill the space. As the magma fills the space, it begins to pile up to form this ridge. It then separates and creates the mountain. A key part of a volcano is the magma. Where magma is stored is called an igneous intrusion. A batholith is an irregular, very large shape. A stalk is an irregular shape that is smaller. A laccolith is a mushroom shape that melts the rock above it, creating an arch. A dike is a vertical or diagonal cut, and a sill is a horizontal to the rock layers. Igneous intrusions are formed when the magma melts the surrounding rock in different ways. It then creates the pockets in which it sits. In this diagram, the purple represents, along with the blue, the different layers of rock that are in the crust underneath the volcano. The red represents the magma. How I'm erasing parts of the rock represent how magma would similarly melt away the rock to create the pockets. The batholith, the large irregular shape. The stock, the smaller irregular shape, the dike, the vertical, the sill, the horizontal, and the laccolith, the mushroom shape. Volcanoes form in several different spots. 1. A hot spot. 2. A volcanic belt. And volcanoes also produce something called tephra. This is a hot spot. A hot spot forms in the middle of a tectonic plate, where the magma and molten material under the crust circulate and create a hot spot. They melt the crust above it and slowly raise the crust, making layers with its magma. As the layers build, it forms an island and volcanoes. A great example is Hawaii. Next are the volcanic belts. The volcanic belts are located on the borders between the oceans and the continents. When they converge or come together, the oceanic plate subducts or goes underneath the continental plate. After the plate subducts, it melts and the magma is forced upwards, creating volcanoes. The main volcanic belt is located here. This is called the Circumpacific Belt. This diagram demonstrates tephra. Tephra are the objects flown into the air as a volcano erupts. These objects may be hard rock, molten, or dust. There are three main types of magma in volcanoes: basaltic, andesitic, and rhyolitic. A key word to know while understanding the different types of magma: viscosity. Viscosity is a material's resistance to flow, so the higher viscosity it has, the less flowy it is. Basaltic magma. This magma has a very low viscosity. It forms from rocks that melt as it protrudes through the crust and upper mantle. With its very low viscosity, it flows very easily. It tends to form basaltic rocks. It has a very low silica content, which creates the low viscosity. It also has no to little dissolved gases, which lower the viscosity as well. Andesitic magma. It has an intermediate viscosity, so it doesn't flow extremely easily, but it also does not completely stop. It has about 60% silica, which raises its viscosity. Andesitic magma is formed from melted and subducted oceanic crust that is then forced back up into volcanoes. And finally, rhyolitic magma. Rhyolitic magma has an extremely high viscosity, so it barely flows. When it erupts, it causes more of an explosion. Rhyolitic magma is formed from a mix of molten material as the molten material mixes with overlying rock. It creates the texture of the rhyolitic magma. Along with the different types of magma, there are also different types of volcanoes. Shield cone, cinder cone, and composite. A shield volcano Shield volcanoes have a round base with extremely long, gently sloping sides. The shield volcano is formed from the hardening of the multiple layers of magma that build up as it erupts. It's very low viscous magma. This creates the gentle slopes. Cinder cone volcano. Cinder cone volcanoes have extremely short, steep sides. It's a very small base. Cinder cone volcanoes are formed from the layering of material that is ejected when erupting. This material then floats down to the surface and piles up, similarly to an anthill. It's much more explosive than a shield volcano. Finally, a composite volcano. Composite volcano has medium sloping sides that dip in as it goes down. Composite volcanoes are formed from alternating layers of magma and different debris ejected when erupting. These eruptions have potential to be extremely explosive and very dangerous to humans. A key part in the happening of earthquakes is stress and strain. Stress. Stress is the amount of pressure put on one area of a certain material. Strain. Strain is how the material reacts or bends according to how much stress is applied. Sometimes, when stress is applied to a material, it goes through elastic deformation. It bends and then comes back. Other times, it goes through ductile deformation. It bends and doesn't go back. Sometimes, a material is bent so far that it neither bends and bounces back or bends and stays. It will break. When a material in the earth breaks, it is called a failure. When a material fails, this creates an earthquake. Where the material breaks is called a fault. There are several different kinds of faults. A reverse fault, a normal fault, and a strike-slip fault. A reverse fault. A reverse fault destroys or gets rid of some of the crust. It happens when the tectonic plates are compressed and come together. One plate then slips up over the other, creating the ledge. Normal fault. A normal fault will create a steep hill. Normal faults occur when the plates separate, creating tension as they pull apart. This will create new crust on the Earth. And finally, the strike-slip fault. In this fault, the two plates will slide past each other, sometimes creating a ridge. One will go one direction and the other will go the opposite. When these faults occur, at a point called the focus, seismic energy, or the energy created by the slipping of the plates, is released. These waves then, in turn, create the earthquake and the waves that rattle the surface. There are several types of waves created: a P wave, an S wave, and a surface wave. A P wave. A P wave is a wave that moves in the same direction as the force. It also is the fastest and the first to arrive to an area. Next, an S wave. An S wave moves at a 90-degree angle to the force that is applied. S waves are the second to arrive. Finally, a surface wave. A surface wave is a wave that moves in both up and down and side to side directions. This wave moves across Earth's surface and creates most of the destruction on our homes. Earthquakes happen in similar zones as do volcanoes. The Circum-Pacific Belt located here. This is where the plates collide and create the earthquakes. There's also another belt, the Mediterranean Asian Belt.